It's time for 1.7. Yes! 1.7. Use interval notation. Find intersections and unions of intervals. Solve linear inequalities. Recognize inequalities with no solution or all real numbers as solutions. Solve compound inequalities and solve absolute value inequalities. Okay? We're going to go over all of that today. All right? You ready? I know you are. So first of all, inequality notation is the one you're most used to. Okay, inequality notation. And it looks like this. X is greater than 12. Okay, if x is greater than 12, in interval notation, which is our objective, interval notation, it looks like 12 to 100. No, to infinity. Everything greater than 12, so it starts at 12 and goes to infinity, right? Now, it's not including 12, it's just everything greater than 12, so I'm not including 12 right here, okay? And then the graph would look like this. Here's 0, here's 12. Two options here, okay? First of all, I could say an open circle on 12 going that way, okay? The other option that I have that you haven't seen before in Algebra 2, because we don't really talk about it this way because it's not anywhere in our curriculum or anything like that, is it could be like this. Just like what's on that side of the 12. Does that make sense? Okay. So another possibility, it could say x is greater than or equal to 12. Now the only difference this time is it's a bracket with the 12 because it actually includes the 12. Now how come we don't have a bracket, God bless you, how come we don't have a bracket on the infinity? Yeah, do you know where the infinity is? Neither do I. I don't know where the end is, so I just say all of it, okay? And we notate that by using the parenthesis instead of a bracket, all right? So greater than or equal to 12. Well, here's 0 and here's 12. My two options are either a closed circle, like this, with an arrow going greater than, or I can go from 0 to 12 and do a bracket, pointing that way. Does that make sense? Now, in Algebra 2, we did these two. We did the open circle and the closed circle. But understand, these are also possibilities. I just wanted you to be aware of them and to have seen them before. Okay? So what if it looked like this? 2 is less than or equal to x is less than 4. What would that look like in interval notation? Well, it's from 2 to 4. We just have to figure out what to put around them. Okay? Is 2 included? Yes, because of the equal to, so that's a bracket. Is 4 included? No, so that is a parenthesis. Okay? So on a number line, I've got 0 and 2 and 4. So it's going to go from 2 to 4 with a line in between it. Or it could be a closed circle and an open circle with a line in between. Okay? Any questions about that? And just depending on, I mean, I could give you a whole bunch of examples on, where this inequality sign is. Maybe it's over here, and then this one is over here. So this one would have the parentheses, and this would be the bracket. Or they could both be less than or equal to, and they would both be brackets. Or they could both be less than, and they would both be parentheses. You see what I'm saying? So all the combinations of those, that's what I need you to work on. Okay? So that's using interval notation. Intersections and unions of intervals. Didn't do this in Algebra 2. This is new for you. Okay? Intersections and intervals. Intersections and unions of intervals. All right? Two new symbols that you've got to learn is this. Okay? Let's say, first of all, that my answer is this. Okay? So this symbol right here is an intersection. It's like, what do they both have in common? This is the first part. This is the second part. I want to know where they intersect each other. Okay? So one way that you could do that is you could graph both of them and see where they both overlap, just in their graph. I'm not saying it's the only way. I'm saying it's one way. Okay? So if I graph just the first one, 0, 1, 2, 3, excuse me, 4, 5, 6. And it goes from 1 to 4. So 1 is here, and 4 is here, and it's everything in the middle. Okay with that? On the second one, I need to make this one longer. 0, 1, 2, 3, 4, 5, 6, 7, and 8. Because it goes from 2 to 8. And it's everything right here. Well, where do they overlap? Can you tell that they overlap from 2 to 4? Is 2 included? Yes, is 4 included? It's not in this one. Even though it is in this one, it's not in this one, so we can't include it as part of the intersection. Okay? So the graph of the intersection would actually look like this. 0, 1, 2, 3, 4, 5, 6, 7, 8. It will be from 2 to 4. Right there. Because that's what they both have in common. It's what they share in common. Does that make sense? Okay. So then this is intersection, the upside down U. What do you think this one might be? This is intersection. This is union. It makes sense to me because union starts with U and the second letter in intersection is N. That's how I tell the difference. If I really have to think about it. You know what I'm saying? Now, union means one or the other or both. Okay? So if I'm looking at these same things again, these same two, right? It's the same two right here. I'm just looking for the union. The graph of the union is going to be one or the other or both. So I need to spread out for the whole thing, looking at the top two purple ones. So it's going to go from 1 to 8. Does that make sense? So it's going to go from 1 to 8. And everything in between. That's the union. Unions, you like squash them together. Intersection, you're just looking for when are they both true. Does that make sense? Okay. Any questions about that? Next thing we have to be able to do is solve linear inequalities. You guys are pretty good at these, so I'm not going to give you a whole lot of examples of these. But here is one. Excuse me. 3 minus 2x is less than or equal to 11. Subtract 3 from both sides. Negative 2x is less than or equal to to 8. Divide both sides by negative 2. X is greater than negative 4. Look. Why did I flip my sign? I divided or multiplied by a negative number. Okay, when we're solving inequalities, when we divide or multiply by a negative number, we have to flip our inequality sign. Do you remember why that's true? Or is it just a rule that you follow? I can remind you pretty easily. Remind. Okay. 2 is less than 5. Is that a true statement? Yeah. If I add something like 8 to both sides, I get 10 is less than 13. Is that still a true statement? If I subtract 2 from each side, I get 8 is less than 11. Is that still a true statement? If I multiply both sides by 4, 32 is less than 44. Is that still a true statement? So I've not done anything that would change that, right? Could I divide something by the same thing and it wouldn't change it at all? Is that true? What if I divided both sides by -2? -16 is less than -22. That is no longer a true statement, is it? So in order to make it a true statement, I have to flip that sign to be a greater than. Ooh, that was a weird one. Sorry. Greater than sign. Does that make sense? Okay. Anytime I multiply or divide by a negative number, I have to flip the sign. Not subtracting. Okay. Only multiplying or dividing by a negative number. Okay. X plus 5 is less than x minus 4. How do I solve this one? Subtract x from both sides. 5 is less than -4. Did I do something wrong? No. All I did was try to get rid of this x by subtracting it on both sides. But when I did that, it gave me this statement. Is this a true statement? No. Then it doesn't matter what value of x I put in. Nothing will ever work. That's no solution. That's this next objective. Recognize inequalities with no solution or all real numbers as solutions. Okay? That's one of the examples of no solutions. Excuse me, x minus 4 is less than x plus 5. If I subtract x from both sides again, I get -4 is less than 5. Is that true? Then it doesn't matter what value of x I put in, it will always be true. And for the record, our all real number sign we could use instead. Okay? So, these are solving linear inequalities, right? Okay? And then we have something like this. What if this happens? My answer that I've got to find has to satisfy both of these equations. So what it could have said is this is not there, and it could have said less than or equal to 3 right here. Like two separate, like one whole problem, but it has a middle part, right? So it almost has 3 sides. Okay? So we could separate them into 2 parts like this. We'd add 3 here, add 3 here. Subtract 1 is what I'm trying to say. Sorry about that. Subtract 1. And I get -4 is less than 2x. So I divide both sides by 2 to get x is greater than or equal, greater than -2. Okay? Here again, subtract 1 from both sides. 2x is less than or equal to 2. Divide both sides by 2. X is less than 1. Okay? How would I show that on the number line? Because it says and, I know that those 2 things should touch, right? It should be between 2 values. Does it work out that way? Everything greater than -2. Everything less than 1. Oh, less than or equal to, isn't it? So is it everything in between the 2? You okay with that? Now here's what I was talking about. The other way it could be set up is like this. Let me draw a line real quick for you. It could say -3 is less than 2x plus 1 is less than or equal to 3. Now to some people that looks like a more difficult problem, but it's exactly the same as this right here. Okay? I would still subtract 1 from both sides. The difference is there's more than 2 sides this time. There's another side over here. So I have to subtract 1 from all of the sides. Okay? Negative 4 is less than 2x is less than or equal to 2. Divide everything by 2. Negative 2 is less than x is less than or equal to 1. Isn't that what this says right here? These two answers, isn't that what this says? Okay? Any questions about that? Excuse me. So the next thing on our list of objectives for today is to solve compound inequalities. That's what we just did, for the record. Okay? I did it and forgot to tell you what the name of it was. Compound inequalities means there's more than 2 sides, basically. Stuff going on. Okay? Now, if it would have said this and another equation, or another equation, that means my answer is going to be in one place or the other. So my graph won't look like this, will it? It'll be facing out. Like the arrows will be pointing away from each other without a common place. So that's a compound inequality. Okay? The last one is absolute value inequalities. We talked about absolute value equations in section 1.6, correct? All right? And I said, I just need you to trust me on this one. I gave you some steps to follow. And some of you were like, well, doesn't it make more sense to do it this way? And I said, please trust me. And you said, okay. Okay? Because here's what a problem might look like. And up to a certain point, you're fine. You agreed with me that we had subtracted 7 from both sides to get negative 2 times the absolute value of 3x plus 5 is greater than or equal to negative 20. You even agreed with me that we divide by negative 2. Keeping in mind that we are dividing by negative when we're solving an inequality, so I do have to flip my sign. Okay? You agreed with me to everything up to here. And then I said, the inside has to be 2 possibilities. What are my 2 possibilities? Either positive or negative, right? And so what we wrote was 3x plus 5 is less than or equal to 10, or negative 3x plus 5 is less than or equal to 10. And what some of you said was, why can't we just change the sign on the 10? Well, I understand why you would want to do that, because it seems like it would be easier, right? And in equations, it doesn't really matter. Inequalities, it really matters. Okay? Because if I'm suddenly making this the sign that's different, I have to look my inequality signs. I really have to focus on that, and there's a whole bunch of rules that you have to memorize. I don't want to memorize rules. I just want to use stuff I already know. To use stuff I already know, over here I just subtract 5 from both sides, just like normal. 3x is less than or equal to 5, and then divide both sides by 3. You guys are all in agreement with me on that, right? It's this side that makes a huge difference, okay? Because if I made that side negative, I would have already had to flip that sign, and that's if I remembered, okay? Here, I can either distribute the negative through, or right from the beginning, I can divide by negative 1. And if I do that, I don't have to worry about flipping that inequality sign at all, because it's already taken care of with the rules I already know about flipping signs when I'm dividing or multiplying by a negative number. Okay? So from here I subtract 5, and I get 3x is greater than or equal to negative 15. And here I divide by 3, and I get x is greater than or equal to negative 5. Now, is this an and or is it an or? Some people can tell right away. Some people need to graph it. Okay? If I graph this, I got 0, 1, 2, 3, 4, and 5. Okay? Oh, dang, it's negative 5. Okay, ignore this graph. Sorry. Let's try again. Negative 5, negative 4, negative 3, 2, negative 1, 0, 1, 2. I'm having a rough day with graphing. Please forgive me. Negative 5 is down here. I know that it is including that, so I'm going to use a bracket. And it's everything greater than that, so it's going that way, right? Less than 5/3. Well, 5/3 is 1 2/3, so it's almost a 2. And it's less than or equal. So again, I have a bracket, and it's pointing that way. So am I going to shade together, or am I going to shade apart? Together. And because I'm shading together, this is an and. Okay? Does that make sense? So I could leave the answer like this. This is another place that I don't know. Okay? I could leave the answer like this, or I can write negative 5 is less than or equal to x is less than or equal to 5/3. I don't know if the computer is going to want separate answers and with the and, or if it's going to want this. Do you see why I put it in this order first of all? Least to greatest. Okay, the lowest to the highest. So I can look at my graph and know that negative 5 has to come first. Okay? Any questions about that? Should we do one more of those? Let's do one more of those, okay? Absolute value of 5 minus 2x is greater than 7. Actually, we're going to do two more just for the record. Okay? Absolute value of 5 minus 2x is greater than 7. So isolate the absolute value like we talked about yesterday. Okay, it is. Then we need a positive 1. And we need a negative 1. Okay? Positive 1, I can subtract 5 from both sides and get negative 2x is greater than 2. Dividing both sides by negative 2 gives me x is less than negative 1, right? Good. On the other side, just so that you can see both ways, okay, let's go and distribute the negative this time. That's not what we did last time. Last time we just divided it away right away. If we do it this way, we get negative 5 plus 2x is greater than 7. I would add 5 to both sides to get 2x is greater than 12. Dividing both sides by 2 gives me x is greater than 6. Okay? So this one was a good one to do this on, because think about it this way. If I divided both sides by the negative first, I would have had to flip the sign, right? But then I would have had to divide both sides by negative 2 later on, so I'd have to flip it back. So just something to think about. Neither way is right or wrong. Sometimes there'll be a shorter way than others. Is that fair? Okay. So I need to figure out if this is and or. So I'm going to try to keep myself from messing up too much by just doing that. Are you okay with that? Everything less than negative 1. So parentheses that way. And everything greater than 6, so parentheses that way. So is this an and or an or? This is definitely an or, because they're not facing each other. They're pointing away. Okay? So can I write negative 1 is greater than x is greater than, or less than x is greater than 6? You know how this way I wrote it like in one sentence like this? Can I write this one that way? No, we don't do that. We say x is less than negative 1 or x is greater than 6. Okay? Any questions about that? How are you feeling about these objectives? Do we need to talk any more about these objectives? Anyone in particular, or are you feeling comfortable with them? Good? I see some thumbs up, so that's good. If you need help, always just ask, okay?